Hello everyone, my name is Diksha and I am taking some chapters from 12th standard chemistry. I started with the alcohols, phenols and ethers chapter, and today I am going to do the continuation of this chapter with the chemical reactions of alcohols and phenols. So let us start. So far we have seen about the nomenclature, about the preparation, about their physical properties. Okay, so today we will be studying the chemical reactions of alcohols, phenols and ethers. So first we will start with the acidity of alcohols and phenols. Okay. Now the first reaction in that is reaction with metals. When alcohols or phenols react with metals, what do we get? Okay, so when alcohol is reacted with sodium metal, we get a sodium alkoxide ion. So we will get 2RONA. This sodium being positive will replace hydrogen here, and hydrogen will here we will get separate hydrogen gas H2. Okay, so that will leave. Even if you take phenol, in phenol what we will get? We will get ONA attached to a benzene ring, which is called as phenoxide ion. Okay, sodium phenoxide ion. And here also we will get hydrogen release. Okay, now this sodium phenoxide ion or alkoxide ion, sodium alkoxide ion, why they are produced? Now they are whenever we want to prepare some particular groups. Okay, if you want to prepare alcohol or if you want to prepare any group from alcohol, okay, which in which to benzene ring or to alkyl group oxygen is attached, it is very easy to form the product when you have phenoxide or alkoxide ion. Okay, so that's why first it is converted to the particular ion and then it is converted to the product. Okay, the reactions we are going to see further. So that's why these reactions are carried out. Next is acidic character of alcohol. Okay, now if you see acidic character, primary alcohol is more acidic than secondary and then tertiary. Okay, now what is the reason behind this order is, if you see here, the to alcohol, now this oxygen is from alcohol group, so to this alcohol group what is attached? The alkyl groups are attached. Okay, RCH2. So this alkyl group is attached. Okay, so these alkyl groups have tendency to release electrons or to give electrons. So if these groups release electrons, the electrons will be on oxygen, so density of electrons on oxygen will increase. So if density of electrons on oxygen increases, what will happen? The polarity between O and H, okay, this polar nature will decrease. Okay, see, if we have more electrons on oxygen itself and if there are less if there is less charge over here, okay, then what will happen? The polarity between them will be less, it will decrease. Okay, if I give you example, if there is suppose this tug war game, then we have two different teams. Okay, if one team is very strong and other team is very weak, if suppose in one team we have 10 players and in other team we have suppose 4 players and those players are also weak players, then what will happen? Where there are 10 players, no, that side the attraction will be stronger, they will pull it more strongly. But where there are only 4 players and those are weak players, there the attraction will not be that stronger. So that's why the attraction will be towards the more, where the more people are, the attraction will be toward that only. Okay, so here also what happens, since electron density is more on oxygen, the force will be more on that oxygen side and hydrogen will be, it will not be attracted that much to the hydrogen. Okay, why? Because polarity, the electron density is more on oxygen. So that's why here what will happen, yeah, as compared to other, here in the primary the attraction will be stronger. Okay, but if you see these two groups, that is secondary and tertiary, here since there are more alkyl groups, here 2 alkyl groups, here 3 alkyl groups are attached to the carbon. So since there are more alkyl groups, the attraction here will be weaker than the first one. Okay, so if more and more alkyl groups are attached to the carbon, which is attached directly to the OH group, then the bond between the force between the oxygen and carbon, it becomes weak if more and more alkyl groups are attached. So that's why the force becomes weak and the polarity will decrease. So that's why the acidic character, if polarity decreases, acidic character also decreases. So that's why primary we will have more acidic character, then secondary, and then tertiary. Okay, so this is the concept behind the acidity of alcohols. Okay, now we know that alcohols have acidity, or they are having acidic character, but the acidic character of alcohols is less than the water. That means water is more acidic than alcohols. Why? Because see, if you take a base in which we have this alkoxide ion, and if you take water, if you react water with that, then water can easily give its proton to that base. Okay, so if water can easily donate its proton, and what is the definition of acid? It is a proton donor. So if it is good proton donor, then we can say that it is good acid. So that's why the water is termed as, water is having better acidic character than alcohols. Okay, then next is acidity of phenols. Now acidity of phenols, we have in phenols we have a benzene ring, okay, with OH group. Now this OH group is attached to a sp2 hybridized carbon. The carbon which you can see here is sp2 hybridized. Okay, so when we have sp2 hybridized carbon, that means the polarity of that carbon and oxygen will be more. So since the polarity is more between them, the acidic character will increase. Okay, so here because of sp2 character, the polarity will increase of the phenol group. Okay, then one more thing here we will see that OH, the phenol group to which OH is attached, we can easily ionize the phenol group, okay, into this phenoxide ion and H plus ion. Now why this is possible? Because see, here we have OH group attached to the benzene ring, which can be easily ionized into phenoxide ion and H plus ion. Now see here the electron density and on O minus, okay, is now here we have sp2 hybridized carbon. No, so electron density is not that much on the oxygen. So since electron density is not that much, here we can have a more attraction between O and H group. Okay, so that's why acidity is more, polarity is more. Yeah, now how ionization takes place here? Now ionization, we have O and H group here. Yeah, so what happens here is the negative charge on the oxygen atom is delocalized since it is conjugated with the benzene ring, meaning here we have OH group with benzene ring. So here we have conjugation of these double bonds in the ring. That's why the negative charge on the oxygen is delocalized. So since there is delocalization, the negative charge is not localized on oxygen itself. So that's why it can rotate along the ring. It can go, it can move here anywhere in the ring. Okay, so that's why it can be easily ionized. But if you see in normal alcohols, the negative charge on oxygen is not delocalized. It is only localized to the oxygen. So that's why here ionization takes place slowly. Okay, so it will not be that great. It will not take place to that much extent as in phenols. Okay, so ionization in alcohols will be little less than the phenols, because there is localization of negative charge on oxygen atom. Okay, now next is about the acidic character of phenols. Okay, now since we know phenols, Okay, phenols, we have OH group. Okay, we know that the density on oxygen is more. Okay, if we have simply OH group attached, the density on oxygen will be more because of the here we have carbon, so it can donate the electrons. Yeah, it can also delocalize it is delocalized, the negative charge is delocalized, but still if you see just phenol, there is more electron density on oxygen. But what we if attach the electron withdrawing group, that is NO2, nitro group. Okay, so if we attach nitro group to the benzene ring, okay, along with the OH group, then what will happen? This nitro group have tendency to withdraw the electrons. So if this nitro group withdraw electrons, okay, from this benzene ring, then what will happen? The polarity or the attraction between this OH will become stronger. Okay, so polarity of this OH group will be more if we attach nitro group. Okay, so that what will happen when we attach nitro group? The acidity will increase. If we attach more and more nitro groups, acidity will increase more. So if I have 2 nitro groups, acidity will be more stronger. If I have 3 nitro groups, the acidity will be more. So if I have like this NO2 and NO2, in this case acidity will be more. So as you attach more and more withdrawing groups, acidity will increase. Okay, so this is about the acidity of phenols. Now this is the concept which you have to apply when there are questions on acidity, like they will give the compound names or the structures and they will ask you to write in the order, increasing or decreasing order of acidity. So that time you have to apply the concept and accordingly you have to write the answer. Next is about the esterification. Okay, now here what do? We take alcohols, we react with some reagent or compound to produce an ester. So first case we have used alcohol or phenol. You can take and you can add here CrCOOH, which is carboxylic acid. So when carboxylic acid is added to alcohol or phenol, it will give you an ester. Now how this is done? This is a reversible reaction in which you use H2SO4, that is sulfuric acid. So it gives proton and this way you will get an ester. Okay, plus water will be released. Then second is when you take phenol or alcohol and when you react it with acid anhydride. Okay, when you take with anhydride, that is RCO2O, this structure is this way, R dash C double bond O, C double bond O and R dash. So it looks like this. Okay, so when you add alcohol to this anhydride, you get an ester plus carboxylic acid. Okay, then third is this is not reversible, this is irreversible. Now here you take alcohol or phenol with acid chloride. Okay, when you react this with acid chloride, what in the presence of pyridine is a base. Okay, now why do we use base here? Because here this is not a reversible reaction, so here the production, here acid will be produced, that is HCl. So this HCl needs to be neutralized, okay, to continue the reaction. So that's why here pyridine, that is base, is added so that the reaction continues. So here also we get an ester with HCl, that is acid. Okay, and it is neutralized with this pyridine base. Okay, then we will see the reaction of an important to produce an important compound, that is acetyl salicylic acid. Okay, so this is acetyl salicylic acid, which is also called as aspirin. Now here what do? We take salicylic acid and to that we add anhydride. Okay, here we are adding anhydride in presence of some acid. What do we get? We get acetyl salicylic acid with carboxylic acid. Okay, so here we are producing aspirin, which is a very important compound and have a application in this pharmaceutical field. Okay, So this is also an ester which we have produced here. Okay, so this is about the esterification reaction. Okay, and all these reactions involved cleavage of OH bond, meaning what? Meaning the reactions which we have seen here, it involves the cleavage of OH bond. OH bond is broken and then the compound is formed. Okay, so this was about the esterification and the other chemical reactions of alcohols. Okay, we will see some more reactions in the next part. Okay, so yeah, thank you for watching the video.